Hello guys, in this video I would like to explain that what is one sample Kolmogorov-Smirnov test, which is usually called case test, and this test was developed by two mathematicians, and of course in generally and specifically, yeah, their statistic is very close to mathematics, so you can say statistician as well developed, and these both are from Russia. And actually what as Kolmogorov-Smirnov test and for what purpose it was developed. This test you can use to test whether a data is coming from a specific distribution or from a specific population, or you can say the data belong to a specific population or distribution. So you test this. You can draw, of course, histogram or the density of the data, and you can guess from that data, but that may be misleading because sometimes because if suppose we are talking about normal distribution, so normal distribution, it has a specific kurtosis and skewness, and if it is a little more than, if the kurtosis value is higher, then it is, a more peak distribution, and if it is lower, then it has a flat distribution. So sometimes you cannot exactly conclude from those graphical results. They are very important tool, but sometimes, so in that case, you can use KS test, one sample KS test, and test whether the data is, if you guess the data is potentially belong, you can say apparently belong to normal distribution, you can test for normal distribution. If you think the data belong to binomial distribution, you can test for binomial distribution. If you think the data belong to some other distribution, you can test for that specific distribution, and you can draw conclusion. You will get this you can get a p-value, and you can conclude that whether this data belong to a specific distribution or not at some significance level, some specified significance level. So this was just the background, and if you want to see, you can go to Google and see detail. Just Google, just search Kolmogorov-Smirnov test for one sample in detail. So you can click on one of the two top. You can see the one sample Kolmogorov-Smirnov test is used to test whether a sample comes from a specific distribution. We can use this procedure to determine whether a sample comes from population that is normal distributed. Yeah, of course, normal distributed or Poisson or binomial or some other distribution as well. It's not necessarily that we can test normality only. So you can test any distribution. You just guess that from that distribution this data may be. So you can confirm by using Kolmogorov-Smirnov test. You can see this in Wikipedia. You can see this graph and the same details. So if you want to know how you can do this and what is the detail of this test and other thing, you can go and you can see. So this, yes, this you can see this is you can see estimation of the Kolmogorov-Smirnov test. The red line is the model CDF, and the blue line is the empirical CDF. So the difference between these two is the test statistic, the Kolmogorov-Smirnov test, and of course the maximum value of the difference between the two is the Kolmogorov-Smirnov test statistic. So the higher the value, the more probability is there that we reject an hypothesis that this data come from their distribution. The lower the value, the more is the probability that we can accept an hypothesis that the data belong to that specific distribution, whatever the distributions, maybe normal, maybe Poisson, maybe binomial, maybe other distribution. So you can do like that. So you can go Google and you can see the detail, whatever you want. If you have some point in mind, you can write in the comments to this video, and then I can respond. Can provide resources as well if you think you need it. Okay, so now let's go to Python. Just initiate Anaconda, and then we'll go to Spider to see how we can do this test in R. And of course, I want to mention that this test, you need this test and data analysis where when you need some data analysis about the distribution, about this confirmation, this data belong to some distribution, you need this maybe in psychology, economics, econometrics, and any type of data analysis, you can use this test. If you think that you need to confirm the distribution of the data you have. In the next video, we will talk about two sample Kolmogorov-Smirnov test in Python. Okay. Okay, now spider. Okay, it's coming. Okay, let's wait. Okay, this is spider, and this is the code. And this is for two sample. I need for one sample. Okay, and this is one sample. Okay, so you need these two, of course, NumPy and CPy. CPy, SCIPY. You need these two. So just run this, and you know how you can do all the stuff with the Python. So I already started from the very basic, from the scratch, that how you can do Python. I started from installing Python, then the spider, then the anaconda, and each and everything, random number generation, and each and everything. So if you think you don't know what to do now, the link to the playlist titled Data Analysis with Python is mentioned in the description of this video, so you can go and start from the very basics. Very easy. And if you think you need some help, just write in the comments below this video. Run this, and then generate a random data. Remember that you are generating this data, and this data is stored in the sample, and you are generating this data from normal distribution. You already have done this. np.random.no_normal dot normal, and then the mean is 0, location 0, scale parameter 1, and size, number of observation, or 1000. So generate this. This is the sample. Now you have this, and you can click, you can write sample. So you will see the values. No, SAMPLE. Yes, so these are the values. Okay, now perform the case test. Remember that D will store the test statistic, and P value will store the P value from this command states.ks test. So apply this to sample, which is we have like this. And the normal, the distribution is normal. We are testing for normal. You can test for Poisson, you can test for binomial, or you can test for any distribution. So there is no restriction. And then orgs 0 and 1. So this just pass the parameter of the normal distribution. That means 0 and standard deviation is 1, as we have simulated from this parameter. So just run this command. Now you will have the p-value and the statistic. Just print that statistic, and I already told you if the statistic value is higher, this means that there is more probability we reject than a hypothesis, and we can claim that the data does not belong to normal distribution. But in this case, the statistic is lower, so perhaps we will have a higher p-value. Yes, that is 0.99. That's very high. So this means that the data, of course, belong to the normal distribution, as we draw from normal distribution. So this is this is for generated data. If you have your own data, you can read from CSV file, from online resources, which we have done these things earlier. So you can go and watch the videos. That's how you can read the data from CSV file, how you can read the data from online resources. Okay, now this is another data. I'm just generating this data 1, 2, 4, 8, 10, 9, 12, 3, 4, 1, 5, 7. This is the data, and I want to test whether this data belongs to normal distribution or not. So this is the data now in X, and now again the same command, D and P value in the same command. I don't have the mean in the other, like this. So I'm not mentioning this here. Okay, now you can print. Yes. Can you see the test statistic is quite higher, it is 0.84. So perhaps in this case, we will have a low p-value and we can perhaps reject the null hypothesis. Yes, for sure. So you can see there that statistic is high. So the p-value is very low, 3.24 as e raised to the power 0, e raised to the power minus 0.9. So that's very low p-value. This means that we reject the null hypothesis and conclude that this data does not belong to the normal distribution. So we have discussed two cases. One was that belong to the normal distribution. We accept the null hypothesis. In this case, we are unable or we don't have sufficient information to accept the null hypothesis that the data belong to the normal distribution. So you can do this for any type of data as whatever the data you have in your hand. And now we were just testing the above data, the sample data. We just think, assume, think in our mind, oh, this data can belong to the Poisson distribution. Okay, so for Poisson, we just define the lambda, that is the parameter. This lambda Poisson has a parameter lambda. And then just apply the same test to the sample data, which is generated here in this case from normal distribution, of course, and just write the Poisson instead of normal. So Poisson norm, so instead of norm, so Poisson and or lam is this value lambda. So this parameter is passing to the for this Poisson distribution. Just run this command and see what is happening. You can print that the statistic is quite high, 0.80. And yes, the p-value is of course 0. That means there is not sufficient information to accept the null hypothesis that the data belong to the Poisson distribution. That is rejected. This means that the data does not belong to the Poisson distribution, and this is quite obvious because this data belong to the normal distribution. We already tested, and the test it was accepted with the higher, there was much higher chances, higher probability that this data belong to the almost the p-value was approximately equal to 1, that was 0.99. So this means that this data belong to the normal distribution and not Poisson distribution. So this is all about Kolmogorov-Smirnov test for one sample data. The basic purpose is that you can test whether the data belong to a specific distribution or not. So you can follow the theory which I have discussed, and then you can do this in Python very easily, and you can do this for your search or maybe thesis or whatever. So this is all about one sample Poisson distribution, Kolmogorov-Smirnov test. If you have any question or you have any point or need information, please write in the comments and I will try to respond as soon as possible. So thank you very much and see you in the next video. Ciao.